Um, Hello everyone, thanks for joining today's Contributor Weekly meeting. I have a couple of items on the agenda today. If you can see my screen. First one is more like a design demo of the OpenEBS scheduler that we have been targeting towards 0.6 release, especially to answer or like solve some of the questions that are coming from the users with respect to how do you make a controller pod or a replica pod pinned to a dedicated nodes. We'll get into that in detail. And also, as part of that session, we would like to hear feedback on the naming conventions that we are following in the design or like the code. We want to better express it. So feedback is welcome there. And also, like if time permits, post that, I just want to hear from you all on any of the tools that you would like to propose that should get used as part of the different stages of the development and testing or delivery. But I've just kept that as one of the optional items for today. If you want to add any other items, ping me on the chat, or you could directly add it in the contributor meeting notes document itself. I'll share this link in the chat window anyway. Right. With that, it's over to you, Amit.
Yeah, thanks, Kiran. Okay, so I shall share my screen. Okay. All right, I hope everyone is able to view my screen. All right. Okay. Am I audible to all of you?
Yes, I can hear you, Amit.
Okay, fine. All right. So we'll get started. So this presentation is about the scheduler that OpenEBS has to schedule the volume pods. We'll have a look at how OpenEBS tries to schedule the volume pods based on the needs. Right. So this is the agenda of this presentation. Excuse me. We'll have a short overview of Maya API server and its policy engine. We'll also get to know about OpenEBS Volume Controller Pod Scheduling and OpenEBS Volume Replica Pod Scheduling. What exactly is a volume controller and volume replica, which we'll see in a couple of slides. Right. Okay. Before we get deep into the scheduling, this is what a typical OpenEBS volume setup looks like. Once a volume has been provisioned onto a Kubernetes cluster, this is what one would get to look. We can see an application determined by the blue box, which may be a stateful application, typically a DB, database, and the boxes in orange refer to the volume, to a single volume. And if we see, there is something called as CTRL and there is something called as REP. CTRL represents a controller, whereas REP represents a replica. And at the same time, we can see the replicas are, spread out. There is some 3 replicas we can see. They have been spread out across 3 nodes, Kubernetes nodes. Right. All right. So if you see the description on the right-hand side, it says that the volumes, OpenEBS volumes, have 2 types of pods. One is a controller, other one is a replica pod. Okay, the controller pod is a target which connects to the application. That is a ISCSI based sessions are enabled in this controller pod. And the replica pod is the one which accesses the underlying resources, that is a disk. If you see, coming back, all right, coming back to the diagram, the controller is the one which is connected to all the replicas, right? And the controller is the one which establishes a session. so that an application can talk and do the IOs on an OpenEBS volume. Right. So we'll go to the next slide and we'll see. So this talks about the nature of creation, how the volume pods get created, right? Okay. So some of the slides have a bit of animation. So I'll just try to speak as I click on the next buttons. Okay, so OpenEBS runs in Kubernetes, that's for sure, and dynamically creates volume pods when a PVC is created. We'll see the flow now, right? So if you see on the right-hand side, there has been 4 boxes. 2 boxes are, orange boxes, let's say, and the other 2 are blue ones. The blue boxes are the ones provided by Kubernetes. It's the scheduler and the API server. The orange ones are provided by OpenEBS. These are the 2 components of OpenEBS. One is the provisioner component, and the other one is the API server component, right? So the assumption is these components should be present before provisioning a volume, right? The next diagram that we see, the box that we see is a PVC spec. Let's say operator creates a PVC spec. The operator does a kubectl of PVC, and let's see what happens then. Right. So the PVC each is watched by the provisioner, right? And that the provisioner in turn invokes the API calls on the API server. API server here is a API service which exposes some of the REST endpoints. For example, volume create, volume delete, right? So what does the API server do? It creates some specifications, let's say some YAMLs for the volumes to be provisioned. Those YAMLs will be, one will be a controller deployment, that is a Kubernetes controller deployment. Or for example, a Kubernetes deployment that will have the controller specifications. Then there will be a Kubernetes service, right? And the next one will be a Kubernetes deployment that will have the Replica specifications, right? So the controller and Replica here refers to the OpenEBS controller and OpenEBS Replica respectively, right? And let's see what happens then, right? So it talks to the the API server, then makes connections or is a client to the Kubernetes API server. It requests the API server to create these specifications. And Kube API server in turn talks to the scheduler to create these pods. We can see the controller getting created and the replicas getting created. And then let's see what happens. All right. So once this is successful, we see an arrow coming out here. Well, that means that the arrow is the one which happens at the end of all this provisioning. It creates, right? It creates a persistent volume specification, right? And this persistent volume specification will have the iSCSI details, for example, the IQN and all those details, the target portal that are determined after the creation of these orange boxes, right? So the last arrow determines the status of the PVC, if it is bound to a PV or it's like unbound, right? Finally, the last arrow will imply that the PVC gets bound to the PV, and the PV in turn is the one which refers to all those orange boxes that got created, right? All right. So MAPI server can be configured to generate the deployments or pods with scheduling, with required scheduling, for example, node and pod affinity parameters. So this is what is the main agenda for this presentation. We'll talk more about this. Okay. And let's go a deep down into the MAPI server, the way it creates the YAMLs. Okay. All right. So if we are trying to look deep into the MAPI server, like I said earlier, it's an API service which exposes some of the REST endpoints, for example, a volume create. It also has a policy engine, and there are something called volume templates. We'll talk more about these in this presentation. So we will see that these are the foundational pieces via which OpenEBS is able to tune the scheduler to its requirements, right? Okay, so what are the volume templates? These are the set of policies, right? We are calling them as volume policies. For example, one of the volume policy can be Replica Count. Another one can be a storage pool, and so on, like volume, like monitoring, enabled, disabled, tains and tolerations, right? And a policy will have two attributes. One is the name of the policy, and the other one is the value of the policy. All right. Okay. So set of ordered get and put tasks to get the values and put the YAMLs. So volume policies are the ones where we say that they have a set of a policy name and a value, right? However, the volume template has some other thing, has an additional thing called as tasks. Okay, those are known as simple task templates. We'll look into that again as we go further. If we want to touch down briefly on the task, they are the ones which are a set of actions. For example, get a pod, or for example, create a pod, right? So get and create are kind of two actions. All right, we'll talk more about that as we go. Finally, in the diagram, we see a storage class coming into picture. So what is it? So storage class is again a Kubernetes kind, right? It has been there so that the dynamic provisioner, the dynamic storage provisioners can be registered. And what we do here is, what OpenEBS does is, the volume templates are registered into the storage class along with its dynamic provisioner. All right. And this is all known, like PVC will refer to a storage class will refer to the dynamic provisioner. And in our case, it also registers the name of the volume template. All right, so the arrows that we see just now are relevant to the policy engine and the volume templates. So this says that the volume templates are the one which, along with the policy engine, is able to create the Kubernetes deployments, the services, So in this case, in OpenEBS case, it is creating the replica deployment, the controller deployment, and also the controller service, right? Okay. So these are the typical questions or use cases for volume pods. This is again much relevant to the scheduling needs. If you look at the right-hand side, what it says is some of the questions that we see here for volume pods are: can the controller pod be scheduled in the same node as application pod? Obviously, to avoid the network hops in between, right? Then can the replica pods be scheduled on nodes which has the disks? This is again an obvious case for a stateful app, or specifically for a volume pod. It needs to access the underlying disk from a particular node. All the nodes in the Kubernetes cluster may not have those resources. So it makes sense for the replica pods to be scheduled on the specific nodes which have got those disk resources. And finally, one of the questions, this is a very important requirement, is can these replica pods be made sticky to a node? We all know that in a Kubernetes environment, the pods get scheduled, evicted, rescheduled, right, based on the scenario, based on the disruptions, based on the partitions that keep on happening that might happen in the cluster, right? However, in the case of a replica, it is not desired to move these pods to a different node. It should be sticky to that node where it was placed. Otherwise, it involves a data migration, and this also can result in a data loss. Right? All right. So all these questions, all these use cases can be handled, can be answered by tuning the scheduling parameters on the deployments, on the volume pod deployments, right? We'll see how it is done, right? So here comes the solutioning part, right? So the first solution that we will consider is the controller pod scheduling. What exactly should be the solution? So this is what OpenEBS has come up with. OpenEBS controller pods should be scheduled in the nodes which has got the application pods, or let's say vice versa. For example, a application pod is already present or already available in a Kubernetes node, then a controller pod should go and get deployed or get scheduled on that same node. This is known as a controller pod getting near to the application pod, or in the reverse thing, the application pod getting scheduled near to the controller pod, right? All right. So A and B describes the things that I just said. This also should hold true during the cases of evictions, right? For example, there was some disruption that happened in the Kubernetes cluster, due to which the controller moved, right? Due to which the controller was evicted and was rescheduled on some other node. This implies the application should also move and stick with the controller and get scheduled on that node, right? On the new node. Right. So this policy or this kind of scheduling is required for both the first-time scheduling cases as well as the cases where eviction happens. And the second point is OpenEBS wants the controller pods to be rescheduled faster for the main reason that if at all this is not handled quicker, if the reschedule doesn't happen in a quicker way, there will be session disconnections, that is isolated sessions getting disconnected, right? And OpenEBS wants to avoid that. All right. So, so this is the YAML which is configured in a way which will allow the controller pod to be scheduled near to the application pod. When I say near, it means the controller pod as well as the application pod are scheduled in the same node, right? The YAML presented here is just an example, a sample. It's a Jenkins deployment. And what we need to do, or what the operator needs to do, is the operator has to label the Jenkins with this particular key, right? controller.openebs.io/affinity. And the value, which is, for example, here I have given it as pinnet. It should be a unique value, so that this uniqueness is held for the controller to get scheduled alongside the application pod. It's important to have the uniqueness here. All right. The next thing that the operator has to do is in the PVC claim. So this is a claim which this particular deployment should be using, right? In the PVC claim, the operator has to set some of the annotations, right? If you go back, I was talking about labels. And if we come to the PVC, I'm talking about annotations, right? So in the annotations, the operator has to repeat that same label that we talked earlier, which is controller.openebs.io/affinity. And the value will be the pinit, right? And which has to be unique. And then there are two other labels that has to be put in these annotations. One is, that talks about the topology, and the other one that talks about the type of affinity. When I say topology, what does it mean? In our case, typically the topology would imply the host, that particular node. We really don't want a topology to be across a cluster or across a zone. This can be like failure zone, and different kinds of zones can be configured, right? So for this current case, we are just concentrating on the host name, because we want the controller and the app to be scheduled on the host, on that node, right? And again, this affinity type talks about the soft affinity. I will talk more on the soft affinity in the coming slides. For now, just remember that there are two kinds of affinity types. One is soft and the other one is hard, right? Okay. So the YAML that we are looking out here is a task template. is a controller task template. This all belongs to the policy engine that we talked about earlier. A policy engine uses these kind of templates to put or to deploy the controller pod or the replica pod or the controller service. Coming back, so here we see that there are some logic written here which determines the kind of affinity that has to be determined, right? We saw that what we see here is if the affinity types belongs to soft, then this particular set of instructions needs to be present in the pod, right? So what are these instructions? This soft indicates that it should be a preferred scheduling and ignore during execution, right? So this is again a type of pod affinity, right? The other types are like required during scheduling and ignore during execution. When I say prefer during scheduling, it means it is preferable to have the controller schedule alongside the app, but it's not mandatory, right? So hence the term soft, right? So what does it have? Is the key. The key has to remain the same, right? Whatever we have proposed, and the value will be the one which was provided alongside this key. In this particular example, the value should be pinit, PINIT, the one which we talked about earlier, this one, right? And all these, transformations, but we don't see the value here, right? We see some templating, some curly braces along with some templating. So these are, this is very similar to the Helm template. If you have heard about Helm or used them, this is, you already know about what I'm talking about here, right? Right. Again, the topology key will be replaced here with the host name, right? This is the one, kubernetes.io/hostname. That particular value will be replaced here. So finally, what the policy engine will do is, if at all this is a soft affinity, and if at all the PVC says to pin or to have the controller schedule alongside the app, the policy engine will be able to understand that, and it will push those kind of policies inside the controller pod specifications, right? All right, we'll go to the next one. I talked about soft and hard, so affinity. So if at all the affinity is not of the category or of type soft, it belongs to the hard category. So here it's all about, there is nothing called preferred, it's required. If you see this particular line, it's called required. Required means it is mandated, right? However, there will be cases where we don't really want to have this kind of hard affinity. For example, an application was deployed on a node, right? However, that node has exhausted its resource, right? Now we are having our controller pod with a hard affinity, with a hard pod affinity. But this means because the node has consumed all the resources or exhausted all its resources, the controller pod will always be in a pending state. It will never get scheduled, right? So there can be scenarios or there can be impacts when we have this hard affinity in place, right? Obviously, there is also an impact if you go all with soft affinity. Soft implies preferable. It will have a best effort. The Kubernetes scheduler will give a best effort. But if it's not found, it will put these pods in different nodes. So we have to take careful decisions on this. Right. So I'll move to the next one. All right. So this one talks about how to make the controller reschedule fast. Right. So for that, the policy engine tries to do something. What we see in this in this slide. It tries to set up some tolerations, right? So what are these tolerations? If you see the tolerations type or the tolerations key belong to node not ready, and there is another type called node unreachable. Well, so these are some of the taints that the Kubernetes puts on the nodes when those node experiences these kind of problems, when the node is not ready or the node is not reachable for some other reasons, Kubernetes will set taints on those nodes, right? And here the policy engine is already knows that there can be scenarios where the taints will be applied by Kubernetes, right? So the policy engine tries to tolerate those taints, right? So what does it mean by toleration of taints? It says I will tolerate the taints for 0 seconds, right? That means in the event when the node which has hosted the controller pod gets into an unreachable or not ready state, that particular controller pod will be evicted immediately without waiting, right? So this is all about toleration seconds as 0.
Hi, Amit.
Yeah.
I think we have reached a logical state where we've covered the controller pinning. So maybe and we've covered a lot of technical terms here. Just want to hear out if people have any comments on the Kubernetes concepts itself. For example, like this toleration seconds, I kind of find it very useful, not just in the context of OpenEBS, but generally if you are trying to run some critical services or pods in your environment, you can directly apply these specs, right, onto that. So I just want to pause for a minute and see if there are any initial comments or thoughts that people have. And is the concept of task template, volume policy, have they synced in, or any questions there? All right. So it looks like people are able to follow it. So let's move on.
All right. Okay, we were telling about toleration seconds. We'll move on to the next one. So this is the end-to controller scheduling, right? This is how OpenEBS tries to manage controller scheduling. Coming to the Replica Pod Scheduling, right? What are the essential requirements for scheduling a volume replica, right? So the first one is it needs to be scheduled on the preferred nodes. Obviously, the nodes which will be having the preferred disks, right? The disk resources. And the second one talks about having a good number of replica pods. When I say good number of replica pods, it implies it ideally should have 3 pods, so as to have a so as to have the HA in place, right? The high availability in place, and to also ensure the quorum. There is a concept of quorum in the replica, so that the quorum is supported. Right. The third one talks about spreading the replicas across the nodes. Obviously, to have a good high availability, we would like to have the volume pods spread across nodes rather than one or multiple pods getting scheduled on the same node. Why? Because if that particular node goes for a toss, we will be losing one or more or all the pods. So it's good to have good to spread the replicas across the nodes. Right. So the fourth one talks about pinning. Right. So how do we ensure that the replica pod gets it's sticky to the node? Right. We are calling the term pinning. We are calling the term stickiness. Right. We want, once the replica pods get scheduled onto a node, it should stick there forever. Whatever may be the scenario, whatever may be the disruption, whatever may happen to the cluster, it should stick to the node. Right. So this is completely different from the one we were talking about in the controller pod, where we want the controller pod to move immediately in case of any issues, rather than wait in the queue, right? So this is all about the replica pods, the essential characteristics of replica pod scheduling. We'll see how OpenEBS is managing to do this. All right. Okay. The spec that we are seeing here belongs to the volume template. Right. We talked about volume template and policy engine. this is the same template, right? So here we are giving a policy called node affinity required scheduled ignore exec. This is a big thing. It's a big term. We can actually talk about renaming it. I mean, that is pending. The reviews are pending here. But let's, for the timing, talk about this particular, whatever details are present in this specs. Both the things, if you see here, both the names refer to node affinity. One of them refer to required, other one refer to preferred. This is again coming back to hard versus soft requirement, right? There may be conditions where the replica pods, where the operator wants the replica pods to be scheduled on some particular nodes, right? This is the piece where the operator has to configure so that it schedules to those nodes. If you see the example again in this slide, I've written about some key called beta.kubernetes.io/os and some value called Linux. Well, these are the typical labels that a Kubernetes puts on a node. Kubernetes understands if the node's OS, for example, if it's a Linux, it will put it as Linux. If it's some other thing, then it will obviously put those other values here, right? So here the operator needs to know beforehand what kind of labels are set in the nodes, right? Or the operator can set the labels on the nodes, right? So that is known as tainting the node. Operator can give a taint to the node, giving its key and a value, and then the operator has to come back to the volume template and put those key and the value here, right? And this is what, and the second one talks about the same thing that I said just now. Let's say there is some key called storage and some value called SSD, right? So key and SSD, the storage and SSD are the taint, like that has been, for example, it should be a taint which has been proposed by which has been enforced by the operator on some node, and if the operator wants the replica pod to be scheduled on that node, the operator has to do this kind of affinity, has to set this kind of affinity, right? Policy engine will in turn understand these affinities and will push these policies on the replica pod. Okay, right? So this is essentially the logic which tries to determine the kind of node affinity, and it will push the policies here, right? Again, since we have, if you see, since we have required and preferred, we have differentiated or categorized the hard and soft affinity, and both the things can be specified together if it is desired. The logic which is present in the task template, the replica task template, ensures that this logic is conveyed during the creation of replica pod. So these are some of the logic that does that, right? This one talks about the required stuff. The next one talks about the preferred stuff. These are nothing but it will push those policies that was specified by the operator, right? Okay, we are on the next essence or the characteristics of a replica pod, which is ensure some good number of replica pods. For example, we always advise a minimum count of 3. And so this is where, and in the volume template, operator has to put this, right? Replica count as 3. And in the task template, that gets converted into the replicas, because that is obviously OpenEBS deploys a replica as a deployment. And Kubernetes has a specification, has a policy called replicas. We just have to enforce that rule, which we have to just enforce this rule on this particular statement, this particular property. All this is done by the policy engine. All right, right. So the third characteristic that we're talking about, we talked about, was about spreading the replica across the nodes, right? So this is what does that. This specification is again in the replica task template, and I have actually bolded out some of the properties. For example, labels. These are typically the labels one will find on the pod, right, on the replica pod. And the property that enables spreading is the pod anti-affinity, right? So let's talk a bit about pod anti-affinity. It means the pods will repel the other pods, right? Pod repels other pods. How? If the in this particular example, if the labels match. Okay, so because we are pushing all our replica pods with the labels, with the same labels, right? And we are also mentioning, we are also setting a pod anti-affinity which says match these labels, and if at all the labels match, you repel them, right? So if you see this block of, or this set of labels are again repeated here in this match statement. This is a very simple logic where a replica pod will match another replica pod. And obviously, a replica pod belonging to volume V1 will not repel a replica pod belonging to volume V2. Why? Because of these constraints. So we have volume owner, which is nothing but the name of the volume. So it understands like which particular replica pod to repel, rather than trying to repel all the broader category of replicas. Okay, we are on to the last desired characteristic of a replica pod scheduling, which is about pinning, right? So whatever policies we apply to replica pod doesn't guarantee that the replica pod will stick to the node. However, OpenEBS wants that to happen, right, for a number of reasons, for the data gravity reasons and so on, right? So how does the policy engine manage this particular requirement, that is pinning the replica pod? If you see the volume template, right, we are mentioning it as volume policy, but I'm mentioning it as volume template. Again, this is open to changes. We'll see like if volume policy is a good term or volume template is a good term. Okay, coming back, if you see the one in the orange lines, it refers to something called volume replica patch. Okay, now what is that? If you see this particular YAML refers to a set of tasks, right? And these tasks are actually ordered tasks. In other words, in this particular slide, if you concentrate on this particular YAML, the volume service task will be executed first, and then the path, then the PVC, then the controller, and so on. And at the end, we'll have the replica patch task to get executed. Okay. So now what is this replica patch thing we are talking about? We'll see that. Right. So this is that replica patch task template we are talking about. It all boils down to a Kubernetes config map, right? So let's not focus on the config map and all the stuff, but let's see the name, right? This is the name, the volume replica patch template that was referred to as here, which in other words indicates all these templates are nothing but config maps having that particular name, right? And all these templates should be pushed into a namespace called default. If at all these templates are present in some other namespace, for example, some XYZ namespace, then this should be XYZ. The search namespace should be XYZ, right? All right. Coming back to the replica patch task template, we see something called as meta. This is very, very core to the policy engine, the OpenEBS policy engine, right? It understands all these properties known as queries, action, object name, patch, and all those things. Okay. So here the action is patch, and we have something called patch spec, P spec. It implies a patch spec. So what does it do? The policy engine will patch the replica pod with something that is present here, right, in the P spec. Okay. And when I say the policy engine will patch the replica pod, that essentially boils down to invoking Kubernetes patch API calls. Okay. Going to the details of the patch. So it again will patch these particular settings, and these are nothing but having node affinity with node selector, like matches. Okay. If you see the second half of this YAML, this talks about something called Kubernetes hostname in a particular value. Well, this is nothing but it says that the policy engine determines the node on which the pod got scheduled. Okay, take out that node name and put that node name in this node affinity. Okay, so once that is done, the scheduler will never be able to take that pod and put to some other node, right? Because we are pinning that thing by the help of node affinity. Okay. All right. We will quickly. So this is a continuation of that patch. Rather than looking more into this is all about logic. We will try to get into the demo. And before I get into the demo, let me know if there are any questions, any queries from the presentation. All right. The demo that I'll be doing is the same one that I talked about in the presentation. I'll be doing this demo on a Minikube. So I may not have I may not be able to really display all the behaviors here because the node is a single node. However, I'll try to explain most of the stuff. Okay. All right. And before I run the steps are all present in this particular folder location. That's OpenEBS Community Feature Demos, Volume Policy, Replica Pinning. These are the setup steps. Everything is all mentioned. One can go ahead and can follow this README and then run the steps. So till this point, it was all about explanation of things, the same things that we talked about, right? And if you come to the setup section, this is all about running the steps. Okay, and you run it, and at the end you can tear it down, right? Some of the references and all are there. All right. So what I will do is I'll directly go to the okay. I'll directly go to this last couple of steps, right? Okay. One can do a JIT loan, of this particular repository, right? It's the same one that I was showing on the browser. Okay. These are the set of files that are already present. Some of them are, only for understanding purposes. You can just open it up and have a look. But these are not the ones which are generated by the policy engine. Okay, so this is just for the understanding purposes. The ones which are prefixed with mock, right? Okay. So we will go ahead with some of the commands, CRDs. Okay, let's see what happens. So we have been talking about the policy engine and the volume templates. Those have been configured as CRDs, which is custom resource definition. And this is what you get. I have created one custom resource definition called volume policies, right? And after that, I'll run a series of steps which are all embedded in this YAML. Have a look at this. All right, so that YAML had all these things. For example, it created a namespace. It created a couple of config maps. That's Red Prometheus, which we are not discussing today. And it also created a couple of storage classes. We are not bothered about all the storage classes. Only a specific storage class is the one which we'll be concentrating. It also created a service account. And it created some other CRDs called storage pools and claims. We are not looking into them as well. It created some cluster role and role bindings, which are essential, which are required. I would advise one to have a look into these, right? What it contains and how it actually helps us. Finally, the most important thing is it created a deployment of the API service, right? Okay, so one thing to note here is I have not deployed the provisioner. I'll be demoing the entire policy stuff, the scheduling stuff, only by doing REST calls to the API service. That is a curl calls, right? And again, let me okay. This is again the specifications of the API service. Look at the image. It refers to 1310. This is one of the private image tags. This is because it has the changes that I'll be demoing now are not pushed into the Maya. It will be pushed into Maya shortly, mostly by next week. However, one can use this particular tag to verify the things that I'll be talking about now, right? Okay, so what we did was we created all these things, right? And we'll run yet another command of kubectl volume policies. All right. So volume policies, this is the YAML that I had been explaining in the presentation. I had been taking some of the snippets from this YAML and putting in the slide deck and trying to make all of us understand that. Those things are all present here, right? And if one remembers what is what are the volume policies, those are, one thing is a volume template, and it consists of a set of tasks. We were calling it as a task template, right? And all the task templates are a set of config maps. All right, so these are the things that I had been explaining in the presentation. We are concentrating on a storage pool called SSD, on a PVC called whatever is written here, right? On a storage class. Again, this volume policy is the custom resource, right? The custom resource object. And these config maps are the task templates, which are referred from the volume policy. Let me open up one volume. Let me open up this volume policy to make things clear. Right. So this is the volume policy that got created. It has a set of policies like volume monitor, the image, controller and replica image, the replica count. Okay, this is one. I'm not making it 3 because it's a mini cube. And then it refers to a storage pool called SSD. If you remember, there was a storage pool SSD that got created. We'll have a look into that as well, right? So this is a storage pool SSD. And then we have something called these things like taint tolerations, right? Okay. There is something called eviction tolerations. Anyways, I did not talk about these things, so let's skip it. This is something we talked about today. So I have it here, right? And okay, I was talking about the namespace. This is the default. All these things were got created in the default namespace. And these are the templates. These are the task templates, which is nothing but config maps, right? These config maps. All right. Okay. We'll have a look into the storage pool SSD minus YAML. Right. So this is the storage pool I was talking about. It has a path. So the significant thing here is just have a look at the path. It refers to something called var my EBS. All right. Okay. So we'll go to the Readme. I cannot refer to the Readme here. Okay. So see, we have run this step. We have run these 2 steps as well. So we are at. I actually purposefully skipped out all those things, right? I had done this earlier. You can do it before running these things. this essentially is doing the Helm installations and all, which is not mandatory. You can actually use just Git clone and do the stuff, right? Okay, so we are going to the run state now. The first command is essentially a verification if Maya is running properly, is running or not. Right. So what you see is this is a service. What I have tried to fetch the services that are running on default namespace. What I should do is rather have a look at the services that is running in a namespace called OpenEBS, right? And here is the Maya API service that we are interested on. Okay, right. kubectl. Okay, then we will see if Maya API service API pod is running or not. Yes, that is running. This is the one. Okay, we are not bothered about Grafana and Prometheus today. All right, so what I will do is I will copy this. I hope that this is the one. All right, this is the same thing as this one. Okay, I'll run it. Okay, so one can notice if one has run this kind of commands earlier using curl commands, you'll see that this has become a bit slow. The reason is the policy engine tries to wait for the replica pods to get created and get the node name, because the node name is not available by default when the creation is happening, right? All right, so I just so if you see, actually we have missed some cycles here. A replica pod was there running, okay, but then it got patched, and that's the reason why it's showing in a container creating state, okay. And if you see the this is RS, this is Replica Set. That is something called this, which had happened 1 minute earlier, right? I'll just clear out the screen. All right, let's talk about this thing. This RS is known as a Replica Set, right? So if you see the last line, right, it talks about one Replica Set that had got created 1 minute ago, right? But it's no longer available, okay? And you can see another Replica set that got created and is ready, that is a running state. And nothing has happened to the controller. So the controller has not been patched. This essentially talks about the patches. I mean, it kinds of gives some hints about the patches that has been done. Using these, we can actually roll back the replica, right, to the older one. Well, that was it about Replica Set. And so if anybody has query about how a Replica Set got created, that's because OpenEBS schedules deployments, right? So a controller is deployed as a Kubernetes deployment. A replica is deployed as a Kubernetes deployment. Deployment in turn creates the Replica Set, which in turn manages. So deployment manages a Replica Set, and Replica Set manages the pods, right? So the pod is the lowest unit of work, if you want to term it in that way, right? And obviously we will have the deployments, right? The controller and a replica. We will have a look at the pod. All right, so I have opened up the controller pod. Let's see what has been here. All right, so if you see, the policy engine was able to determine some of the affinity terms, right? That is required to schedule the controller pod alongside the application pod, and this is what it has done, right? How it has done it. We'll just have a look. Kubectl get PVC, right? So if you see that it's in a pending state. This is only because I have eliminated the provisioner in the picture here. What the Maya API service does is it queries this particular PVC, gets the affinity details, and puts those details in the controller pod YAML here, right? We'll have a look at the PVC. Just a single PVC, so we can have a look. Yeah. So if you see, like we discussed in the presentation, the annotations has been set with these stuff, right? And here is the term soft, and definitely the soft will translate to preferred, right? So this is the preferred thing, right? So all these things would have made sense if an application was running that had a label called controller.openebs.io/affinity :pinit, and then it would have been a multi-node. Then we would have seen that this would have gone stuck to the node where app was running. Just because I don't have those things now. All right, so we'll straight away have a look at the Replica pod. Right, so there are so many things we talked about on the Replica pod. Let's go through them one by one. Right. The first thing that the simplest thing that we talked about was the number of replicas as 3, but I saw that I was using replica count of 1, and hence we have got only a single pod, right? So let's not talk about it. We'll talk about the node affinity. You can see that these are some of the things which we saw in the volume policy that has come and has been set here, right? This is the preferred stuff. This is the required stuff. This is all about node affinity, right? We talked about this thing, right? All right. So if you see, this is of special significance. This particular, this particular segment block of YAML. The first thing, if you see, the first match expressions, if you see, right, this has come from the volume template. Okay. The next one has been done dynamically. Okay, the next this particular thing was done due to the patch operation, right? So this patch operation in turn says that to stick the replica to this node, right? This node. Okay, so for more clarification, if you see, if I do a get node, okay, just wait. Yeah, so this is the node, right? So obviously this is the only node here, but nevertheless, it has got this particular node information and it has got it stuck into the replica pod. Where is it? Yeah, this is the one, right? And we were also talking about spreading the replicas, and this is the policy for that. That is a pod anti-affinity, and we see that these has also been taken care of, right? All right, I'll just do a get volume policy. Right, if you see, that is this thing was set in the node affinity in the required statement. This was set in the preferred statement, but there is nothing called set that particular host name. That was done by the patch. And okay, so this is the volume policy I'm talking of, right? And to those observers or the curious observers, if you see the volume policy, right? This doesn't have anything about controller affinity, right? Why? It's because this is a dynamic requirement which will be given at the time when the applications are scheduled, right? This in turn implies the data will be available in the PVC rather than the volume policy. So the policy engine is smart enough to understand that, and it queries the PVC, get those controller affinity details, and pushes that to the controller pod, right? PVC minus zo YAML, right? So the PVC is the kind, is the deploy, is the Kubernetes object which has got the controller affinity details, right? Okay, so this ends my presentation, my topic here. Any questions or any suggestions? Just we can talk about it right away, or maybe we can post that on Slack later. Right?
Hi, Amit.
Hey, hi.
Thanks for this session. It was really informative. One question, Amit. So with respect to the replica consideration, replica scheduling considerations which you showed, is there any plan of including the pod disruption budget? That should be helpful when we are doing rolling updates, etc. To ensure that some of replicas are available, because since we are also discussing the quorum and keeping it in different nodes, there's something, some thoughts of that as well.
Yeah, so that should be considered as well. Basically, this policy engine has got a framework, and we can actually try out different policies. So the pod reception budget, PDB, right, is one such policy we can try out. It's definitely worth trying, and I can see that we don't require a code change for that. We have to just try it in the policy as well as in the task template, and that should be possible.
Okay. Thanks.
Amit, this is Vita. Can you hear me?
Yeah, Vita.
Cool. Okay. My question is not sure whether about the presentation related one, but basically in the storage pool, I saw we are using the var / my EBS kind of path, right? So the plans for using a disk information, device information in that one.
Okay, so yes, right. Yeah, so once the storage pool gets the capability. Yeah, I'm able to hear you, Vita. Am I audible?
Yes.
Okay, so Vita, what I was trying to say is, yes, we will have those disk-related informations get into these replica pods. But for that, we need the storage pool to support those stuff. Let's say, for example, if you go to the storage pool, the one we have currently or one we support currently, it only supports the path, right? Once the storage pool comes up with its own support of a disk and so on, definitely the policy engine will be able to take it and push it to the to the replica pod. Or if the policy engine is instructed to use, let's say, the local PVs or whatever the Kubernetes has come up with a local storage, the policy engine will be able to take those information and put into the replica pods as well. It is doable.
Okay, thanks, Amit. Got it.
Yeah. Welcome, Vita.
Amit, Vishen, Uma here.
Yes.
Sorry, I just was dropped off for a while. Not sure if this question was asked in this presentation. So the question is, we are introducing a new scheduler to schedule volume pods according to some policies. That's all good. How is this related to the volume topology scheduler extensions that are introduced in Kubernetes? Does these two features work in tandem, or what's the relation?
Okay, so the scheduler feature that we have introduced actually tries to use the existing Kubernetes default scheduler. We have just tried to tune in some parameters that the default scheduler understands. When we talk about the external schedulers, if I understand correctly, we are talking about some of the external schedulers that have been coming up.
Not external schedulers. My understanding is that Kubernetes default scheduler is extended to have the awareness of volume topology, right? Whenever a pod is getting scheduled, it takes into consideration about the volume parameters, and that's exactly what here we are trying to do with OpenEBS, right? We are trying to hook into the scheduler of Open Kubernetes to tell where it has to go.
Right. Yeah.
I see some kind of intersection there. Wanted to get some clarity.
So the Kubernetes volume topology makes use of the topology parameters that are set on the persistent volume or the persistent volume plane, and makes a decision on where to place the application pod. Right. So when we get a PVC, for example, in this particular demo, we showed that the user has given a topology information in the PVC itself, and we are making use of that to launch our volume pods, right? So let's say the user has not given it. So what we can do is we can actually launch our controller pod based on the best resources that are available. And when we are creating the PV object, we can set, okay, these are the nodes, or like, these are the topology again, like comes into node based or like, fault domain based. We can set up those keys, and Kubernetes volume topology for the PV will take into account those parameters to schedule the application pods.
Okay, so I understand we can work together, right? So there is a clarity in terms of if the developer or the administrator wants to schedule it in a particular way, we have ways to configure the volume policies in OpenEBS, and also to set up parameters on the PVC of Kubernetes for volume topology perspective. Is there a plan that we merge this upstream, these changes, because tomorrow somebody else can change or add more into volume topology? Some of these capabilities are common to all other dynamic provisioners as well.
No, but this is currently kind of an independent thing. This I haven't thought about what you just asked, but my current thought process is this is kind of specific to how do we schedule the volume pods. But I don't see a reason why you can't make it into a generic, templating engine for scheduling the pods that takes into account all the different topology parameters. But we are not taught in that direction anymore.
Yeah, so my worry or thought process is just like some parameters of volume topology are introduced in mainstream Kubernetes, more like more parameters could enter there. And right now, there may not be an intersection of these parameters between OpenEBS and Kubernetes, so they can coexist very well. And later, that may not be the case. So just thinking if we can identify some of these independent parameters that can go upstream, it may be a good idea later on to push upstream.
Thank
you.
Yeah, thanks, Uma.
In very much details. Thank you, Amit. Great job.
Yeah. Welcome, Uma. So, Kiran, probably, do you want to start off with the next set of questions?
I think in the interest of time, we are already like 10 minutes over the planned time, actually 15 minutes. We can probably take up my thing for the next one. So based on like what I heard from different sources, I've just updated the document though with, let me just open up some of the tools. If offline people want to add more or comment on that one, please feel free to do so, or post them on the OpenEBS Slack channel as well. Yeah, I think we're, in the next couple of months, we want to enhance the use of automated tools around the development process itself. I'm looking for feedback and kind of improve that. Are there any more questions, or we can call it a day for today? And thanks everyone for overstaying in this call.